Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So in today's video, I will show you 3 methods to solve the problem, starting from the very brute force approach to the most optimized one. Okay, we will analyze the time complexity also as we go on through these 3 solutions. So let us just try to understand the problem statement at first, because that's the most important thing. So today the problem statement is really simple. You need, given an integer array nums, you need to return the number of triplets chosen from the array such that they can make triangles. Okay, we can form them the sides of the triangle, and this is a sufficient description, I would say, because you should know what are the properties of the sides of the triangle, right? They should not be zero. I mean, triangle inequality should hold true, that is that sum of any two sides must be greater than the third side, and stuffs like that. Those are the things which you need to know, that what are the valid criteria for the sides of a triangle. So if you see an example 2 2 3 4, how many triplets can you choose from this array? Okay, so you could have chosen this 2 3 4. Okay, and you see it forms a valid triangle because any two sides of this triplet is greater than the third side, sum of any two sides. And you can also choose this two, the first two you can choose, followed by the last 3 and 4. Okay, so if you choose the first two followed by the last 3 and 4, you get another triplet 2 3 4, and 2 2 3 is also a valid triplet because that is also following the criteria of triangle inequality. And but if you consider the triplet 2 2 and 4, that is also another triplet, but that does not satisfy the condition of triangle inequality, because 2 plus 2 will be equal to 4, which is not greater than 4, right? So sum of any two sides is not greater than the third side. So yeah, I hope you do understand how this example is working at least. So looking at the solution, only looking at the question, you should first look at the constraint. So you see it is 1000. So for getting accepted, you can do n square or n square log n or stuff like that. Okay, so the thing which you should first try to see is that a very brute force approach should come to your mind. Okay, so what is that brute force approach? There are 3 sides of the triangle, right? So why not we iterate all the 3 sides? Okay, so 3 sides we have, let's say those are represented by the numbers in the array. So let the indices representing them be I, j and k, and therefore the sides of the triangle will be nums of I, nums of j and nums of k. I hope you do get it, and you can use a simple for loop, right? So let's say this is the array, so you see I, j and k, you just keep them in this order, and you can just iterate j, iterate k, iterate I also in a triple for loop in an O of n cube solution, and just check whether this triangle inequality holds true. During this process, you must note that the last index till that I can go up to is n minus 2. Okay, because you see, not index, till the element. Okay, so n minus 3, because I, j and k, a possible last triplet can be this, and I cannot go further than this, j cannot go further than the index n minus 2, k can definitely go till the end, that is the index n minus 1. So I hope while doing the for loop, I hope you can now set the indices for I equals to 0 and I less than n minus 2, I plus plus. Okay, I hope you do get it. And for j, what you will do, you will start from I plus 1, okay, to ensure that they are in order, and j less than n minus 1 and j plus plus. And for k also you can do a similar thing. For k, why I am writing this obvious brute force solution, you will understand at the very end, because the most optimized solution is actually more related to the brute force solution. Okay, so k less than n, k plus plus. Okay, so after doing all of these, you can just check for the triangle inequality criteria, that is, does these 3 triplets actually form a triangle? Does this, the sum of any two sides would be greater than the third side? So you take the first two sides. Okay, so you take the first two sides, and are they greater than nums of k? And you check also that is this nums of j k. So you took I and j, added them and checked with k. So similarly you can just do another thing, nums of k greater than nums of I. Okay, and another criteria, the last criteria, you can just take care. Okay, so I'm not writing this fully. Jk, it will be ik and j here. Okay, so if this is true, if this is all the three statements are true, then you can, let's say, do an answer plus plus in your final value. Okay, and you can initialize definitely an answer 0, which represents the total count. Okay, so yeah, I hope that is clear, and at the end you just simply return answer. So this will be our brute force solution, but because of the O of n cube length, and n is can be up to 1000, you see in the constraint, so it will give you O of 1e9, which will not be accepted. It will give a TLE. It is supposed to give a TLE, so there is no point in coding this out. Okay, so but the whole code I just wrote it. Okay, so yeah, I hope you do understand the brute force solution, and it is not at all difficult. Okay, so now let us try to think how can you optimize this, meaning that how can you remove one of these loops. So an obvious way to start with an optimization process by in these types of problem is definitely to sort the array, right? Okay, so if you sort the array, what will you get? You will see that everything is in increasing order, right? Everything is in increasing order, all of those elements. Now you see, you try to use the same two for loops in the beginning. So let's say you use for I equals to 0, I less than n minus 2, I plus plus. You try to remove the last loop somehow. Okay, so what I will do is that for j equals to 0, not 0, j will be I plus 1, and j less than n minus 1, j plus plus. Now you see, instead of iterating for the k loop, you just try to figure out that you see you have a sum right now. Okay, nums of I plus nums of j. You want to figure out how many such k values are there. So if I is here, j is here, okay, you are adding these two elements, whatever is present, and you must remember that they are arranged in the ascending order. Okay, they are arranged in the increasing order, so you don't get confused. Okay, so you take these two elements and you try to find some k which is greater than which is I mean, you want to find that this k should be less than this sum of I and j. Okay, so let's say k, there is a valid value of k here. Okay, there is a valid element k, then there is a valid k. At some point when the value of k will be very greater, value of nums of k will be very greater, very much big, yeah, it may be possible that this nums of k is becoming greater than or equals to this nums of I plus nums of j. But you do not want that, right? You want the value till which it is not greater. Okay, so you do a binary search. Okay, so in C++ you can do a binary search using, without actually writing the binary search function, you just use this lower bound function. So this lower bound function will give you the an iterator. It always returns an iterator, right? So it will give you an index or an iterator which will be pointing to the first element which is just greater than or equals to your this sum value. Okay, so let's say you pass this lower bound function, it takes the iterator nums dot begin, nums dot end. Okay, and if you are using some other language, you can write a simple binary search also. Okay, it won't be at all difficult. So what will this do? What will this iterator do? It will find a value. It will point to the array, the first element which is just greater than or equal to. So it will, let's say, point to the first element, and this works in log n time. This works in log n time, the best part, because yeah, that's binary search, right? So you find the first element which is just greater than or equals to this sum. Okay, now you see, let's say your I is here, j is here. Okay, now all of these, now you see, if you go further, your triangle inequality criteria will violate, so you cannot go further. So all these elements lying in between j and k should be taken as your answer. right? So you can easily do that. So if I tell you how many elements are lying between this whole thing, how many elements are lying between this whole thing, it will be nothing but the index number of this iterator just before this. Okay, so you can easily get the index number of this iterator by doing it by minus nums dot begin. Okay, it will give you the index number at which this iterator is pointing. And if I tell you from 0 to j, starting from 0 to j, how many numbers are lying, between 0 to j, your answer will be j plus 1, right? That's quite obvious. So you subtract this whole number from here. Okay, so what are you doing exactly is that you are taking all these numbers and subtracting all these numbers to get the number of numbers which is lying between this. So from this whole thing, if you subtract this j plus 1, you will get your answer which you need to add for this particular iteration. Okay, so again you can perform a binary search and add to your answer. So as I will code these things out, it will be more clear to you actually. So let's try to start the coding first. So I will have an n which will be nums dot size. Okay, so and what I will do next is also I will sort the array. So nums dot begin, so that I can easily iterate nums dot end. Okay, so now what I can simply do is that keep two loops, because yes, this n minus 2 it will go till, okay, and j, if you talk of j, that will start from I plus 1 and j can go till n minus 1 j plus plus. Now instead of having another loop of k, I'm trying to say that using a binary search in this sorted array, tell me how far can k travel. So how far could have k traveled, that is what I am trying to find. Okay, so how I can do that? Definitely I can keep an iterator and I can write a lower bound function. You can simply replace this by binary search. So yeah, this actually does binary search and nothing else. So it will take the whole array, okay, and it will tell you this sum greater than this sum. Okay, a number which is just greater than or equals to this sum. Okay, so it just took this sum as your answer, argument, and it will return an iterator which is just greater than or equal to this sum at the point. So basically it points to the index uh, beyond which at or beyond which, okay, not only beyond which, at or beyond which. Okay, so it points to the index at or beyond which the triangle inequality fails. Triangle inequality yeah, fails. So I hope you do understand, right? So what should I add to my answer right now? So I did not initialize an answer with 0, so let me do that also. I initialize this answer with 0, and answer will be nothing equal to so it minus this begin, it will give you how many elements are there till before this point. Okay, till before this point how many elements are there, and we need to subtract the number of elements, which is nothing but j plus 1. Okay, so yeah, I hope you do calculate. So this calculates number of elements between j and k, basically it, which is nothing but your index k in your brute force solution. Okay, so that was all. If you try to just return this, I think this should work. If there is any issue, we will look at it. So let's see. You see, if I submitted this, it just got accepted. If I try to finally submit it, will it run? So you see, we got a wrong answer. So yeah, I deliberately did this to show you that see, this nums is 0, so there may be some elements in between that is 0. Okay, so 0 cannot definitely be a side of a triangle. Okay, so you are expected to get unpredictable kind of answer. So yeah, so you see, if you sort the array, all the zeros is supposed to come at front and it will be first encountered by the pointer I. Okay, so if you get at some point nums of I equals to 0, you can just continue without doing all of this. Okay, without doing all of this. So if you are just telling your code that if you ever see a 0 in the first place, just remove the whole iteration, do not consider anything where I is 0. Okay, so yeah, definitely, and see, these are arranged in an ascending order, so if I is non-zero, then j will definitely be non-zero, right? So yeah, that is true, and yeah, that's all for this, and I hope it should now work. Or is there some other error? Let's see. So you see, we did get the accepted thing, but our runtime is not that great. It is just 15.3%. I hope you do understand that this thing works in login time, and this is an n square loop. So the total time complexity is nothing but O of n square log n. So you see, what will happen is that we will try to optimize it even further. Okay, so let's try to visit our brute force solution and try to understand why exactly this was taking n cube. Okay, now you will tell me that what a silly question is that. You are asking why is it taking n cube? There are 3 loops, so definitely they will take n cube, but it is not that. You see, 3 loops does not always implies an n cube solution. Why? Because you see, there is a reset. The pointer is getting reset every time in the 3 loops. The pointer is getting reset every time in the 3 loops. That is why this 3 loops is taking an O of n cube solution. So what it is happening is that for I, whenever it is iterating I, when it is starting with a new value of j, okay, so the j goes from I plus 1 and goes till n. Okay, then I goes, I just jumps to another place, and j then again resets to I plus 1 and then goes till n, which makes it an n square, O of n square solution. But if you add another pointer k also in your calculation, okay, so let's say I is here and then j is somewhere here, then k starts from j plus 1 and goes till n. Okay, then j jumps and then again k resets to j plus 1 and goes till n. The value is getting resetted every time, and that is why it is giving a O of n cube solution. Okay, so that is the real reason. So do you think we need to reset this k pointer? I am asking you a question. This is a very out of the box thinking, okay, for this approach. Do you think we need to reset this k pointer when we are iterating through this? So what I want to say is that uh, do we actually need to reset this k pointer when this array is sorted? Okay, so in brute force I am not considering anything as sorted, and that's why I check all the 3 conditions. But for sorted array, you obviously understood by intuition that it is not necessary. So you first, if you sort the array, if you take the sorted array, then if you try to write this brute force solution, do you think we need to reset this k? Let's try to analyze this in very detail. Okay, so what exactly I am trying to say is that you had, let's say, a large array. Okay, your I is pointing somewhere, j is pointing somewhere here. Okay, and your k is you are iterating your k till the point where it does not violate the triangle inequality, that is it does not violate the criteria nums I plus nums j is greater than k, nums k. Okay, so till the point it is not violating this criteria. Okay, so you see, but I want to tell you that when you are starting with the next version of j, so let's say this was some ai, let's say this was one a1, a2, and let's say this is some ax. Okay, so you get a point at which for traversing further will give you a violation. Okay, will give you a violation. So till this point you get ax to be less than ai plus a2. Therefore all of these numbers in between, will definitely be, if you consider any number ak, okay, all of this number ak for all this is the symbol of for all ak, it will be less than a1 plus a2. I hope you do understand what I am trying to say, right? For all ak this will be true in between this a2 and ax. So for k between 2 and x, okay, for k between 2 and x, for all k this will be true, okay. You see, in your next iteration, when let's say j moves one step, let's say you are pointing at the element a3. Now you see, a1 was plus a2 was one of the sum, it was the whole sum, okay. Now a1 plus a3 is another sum too. Now you can obviously say that this 3 element has got shifted by 1 and it is arranged in a sorted order, that is, it is arranged in an increasing order. So definitely this sum 2 is greater than this sum, okay. So if you have, I try to say that, where will you need to now shift your k pointer? Do you need to reset your k pointer to then again, let's say, now let's say for the new case, okay, I am drawing it again. Let's say I is still fixed, okay, pointing here, I is fixed here, and j was earlier here, but j has now moved one step here, okay, and it is now pointing at a3. This is a1, okay. Now k was pointing to an optimal element beyond which the triangle inequality criteria will get hampered, and it was pointing to some ax, okay. So I want to say that, okay, if a1 plus a2, this value sum, this was greater than ax, then a1 plus a3 will definitely be greater than ax, okay. So and all the values in between these a3 ax also. So you need to shift k by right, you do not reset k. The main point is that do not reset k, because if this sum is greater than ax, then this sum 2, this value of sum 2 will definitely be greater than ax. So you need some value which is greater than this, okay, you need some further value which is greater than this. So you just need to write the brute force solution without resetting anything, okay. So if you try to see, what I want to say is that you just keep instead of a for loop, you can keep a simple while loop, right? So you can do something like k is less than n, you can go through all the k, and you also keep checking that nums of I plus nums of j is greater than this k nums of k, this also needs to be true. Then you just do k plus plus whenever, and you see you are not resetting. For in a for loop, what you are doing is that you are resetting this k to j plus 1, but you are not doing it right now, otherwise you are doing the exact same thing as the triple for loop. So you see, only one time for this whole thing, a j and k pointer, this whole thing will take an O of n solution, because k does not reset and it is able to traverse only once. Even if it is inside a for loop, still it is able to traverse only once. And we use this trick that answer will be now plus equals to the number of elements between k and j, right? So number of elements between k and j will be k minus j plus 1. I hope you do understand what how this is happening. It is same as the last one. So you calculate all the elements which is happening till here, so that's k. And if you calculate, subtract all of these elements, so from 0 to j you have j plus 1 elements, and just you subtract this j plus 1 from k to get the number of elements which is lying in between j and k. So that's all you need to do. If you try to directly submit this, I hope this should work without any errors. Okay, so it is giving me an undeclared identifier. Okay, so it is telling me that I did not initialize k. What are you doing, man? So yeah, what can I initialize k to? If you try to think, what if we initialize k with something like I plus 2, just for some value to start. I mean, it cannot be less than this, right? k cannot be less than this. If j is immediately after I and k is also immediately after j, then in the best possible case this can be true, k equals to I plus 2. Okay, and I am not resetting the value of k with respect to j, I am resetting with respect to I only. Okay, so if you try to now submit it and check, will it work? It is still giving me a wrong answer for this. So it is telling me that I am using this j as unidentified. Okay, so I just wrote it in this wrong place, right? You can all, I hope you guys can see this. I just wrote it in the wrong place. So yeah, we do have the accepted. If you try to submit it and check, you see we have a percentage bits which is 94%, although the memory runtime is not so good. I don't know why, because we are not using any extra space, we are sorting the same array, and where is the extra space that I am using? Can you find it? I don't think I can. Okay, so but yeah, that's but definitely our runtime is much better because we are using a simple O of n square solution, and the solution itself is very easy, and I hope you did get to understand. If you did not understand any portion, then definitely you can ask me in the comment section, but I hope if you would have used a pen and paper and took uh, listened everything which I said very carefully, you would have definitely understood it. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.